Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at the reactivity of elements. So hopefully by the end of our lesson today you're going to be able to explain the reactivity of different metals and also predict which ones would react with the others. First thing to do though are the three questions we've got based around our previous lesson. So answer those three in your book. Let's go through those answers then. So group 0 are also known as the noble gases. Give yourself a tick for that one. The reason they're unreactive is because they have a full outer shell, or all the electrons in the outer shell are present, or they've got 8 electrons in their outer shell. I suppose you could go with that one. And the final one there is monatomic, means they are single atoms. What I've got for you here then are 3 sentences, and you'll notice that there's pairs of words in brackets. What I'd like you to do is have a go at writing those 3 sentences, selecting the correct word for each pair in brackets. So you won't write both positive and negative, you'll decide if metal ions form positive or negative ions and write just the correct word in. So I'll give you about 3 minutes to do that. Let's mark these then. Obviously, tick it if you get it right. If you got it wrong, write the correct answer in. So metals form positive ions. The more easily this happens, the more reactive a metal is. And a metal can react with water or acids if it is more reactive than hydrogen. So give yourself a score out of 3. What we've got on the screen now are 2 general word equations. Now, these are ones you could very well have met back in Key Stage 3, but they're really important that you know. A general word equation is one where we're not using the actual names of the chemicals that could react. The only time we use a proper chemical name is if it doesn't change, no matter what's reacting. So in our 2 examples here, we've got a metal reacting with water in our first one, and a metal reacting with an acid in the second. So water isn't going to change. That is the chemical name we can put plus water as it stands. And when we react any metal with water, it will still be plus water. Then on the other side, what we form is a metal hydroxide and hydrogen. So hydrogen doesn't change, therefore we can write that proper name, and it will always be a hydroxide. The only thing that's going to change is the name of the metal. So if we had something like calcium, for example, reacting with water, then we would have calcium plus water makes calcium hydroxide plus hydrogen. All we do is we swap the word metal for the name of the metal. The second one, metal plus acid, makes a salt and hydrogen. A little bit more complex because we're not just changing one word. So the acid is obviously going to be one of our common acids. There are 4 you're going to potentially learn about in your GCSE course. And what acid we have determines the ending for the salt. So if we've got hydrochloric acid, then it will always make a metal chloride. If it's sulfuric acid, it makes a metal sulfate. If it's nitric acid, metal nitrate. And if it's phosphoric acid, metal phosphate. So the ending to the salt is always given by the acid. And obviously we make hydrogen there. So write those down, stick them in a box, make sure you know that they are important for you to learn. So what I'd like you to do, put that into practice then. 3 things for you to have a go at on the screen. I'm going to give you about 4 minutes to do that. if we start with the word equations then, hopefully for the first one you got calcium plus water makes calcium hydroxide plus hydrogen. 1 mark if you got that right. And then calcium plus hydrochloric acid makes calcium chloride plus hydrogen. Give yourself a tick if you got that one right. So if we look at the balanced symbol equation then, if we start off with our top, then we've got calcium, which is Ca, plus water, which is H2O, and that's going to make calcium hydroxide and hydrogen, which is H2. Now calcium hydroxide, calcium, which remember is a 2+ ion, and hydroxide, OH, is a single negative. So because we've got 2 positives, what we actually need are 2 hydroxides. So once we've got that, that's our actual symbols. So if you've got that right, then that's worth your first mark. And then what we need to do is balance it. So if we look, we've got 1 calcium on the left and 1 calcium on the right. 2 hydrogens on the left, but we've got 2 plus 2, 4 on the right. And if we look at the oxygens, we've got 1 on the left and 2 on the right. So what we need to do is put a 2 in front of our H2O, and that then gives us the second mark. If we do the same thing for the second, then what we start off with is calcium and hydrochloric acid, which is HCl, and that's going to make calcium chloride. So calcium, 2 pluses on the charge, chloride ions have a single negative, so that would be Cl2, and we've got hydrogen, H2. So if you've got that bit, that's your first mark. And then what we need to do is work out the balancing. So 1 calcium on the left, 1 calcium on the right, 1 hydrogen on the left, 2 on the right, 1 chlorine on the left, and 2 on the right. So we need to put a 2 in front of our HCl to then give us 2 hydrogens on the left to match the 2 on the right, 2 chlorines on the left to match the 2 on the right. And that then will give you your second mark for that one. So add it up and give yourself a total out of 6. So one of the things we need to be able to do is work out an order of reactivity of metals based on experiment results. So see if you can come up with a method that would allow us to place 5 metals in order of their reactivity. Now, there's a couple of different ways you could have done this. We could have used a metal and acid reaction, or we could have used the metal and water reaction. But basically what we're looking for is a method that uses each of the 5 metals, and then we're going to add them to either acid or water, and we're then going to observe the rate of bubbling, because in both of those reactions they make hydrogen gas. So what we can do is observe which ones bubble fastest, and then we can obviously work out which is the most reactive metal from that. So I suggest you jot down those 4 points about how we could carry out the experiment, then have a go at the 2 questions at the bottom for me. Now, counting bubbles is notoriously rubbish in terms of its accuracy. So to actually increase the accuracy of our results, what we need to do is collect the gas in some way, and then we can record the volume. So we've already looked in biology at a range of ways that we can collect gases, and it'll come up again in our later chemistry topics. But we could use the inverted measuring cylinder and collect the gas in there, or we could use a gas syringe. Why we shouldn't boil the water if we're heating it up is because when we boil water, we get bubbles of gas anyway. So that would mean you wouldn't know whether the bubbles were the hydrogen or whether they were bubbles made because you'd boiled the water. Another kind of reaction that we could use to identify which metals are more reactive than others is a reaction called a displacement reaction. And in a displacement reaction, what we find is that a more reactive metal will displace the less reactive metal from a solution of its compounds. And by that I mean, if we've got a compound that has a less reactive metal in it, and then we add a piece of a more reactive metal to that solution, then it's going to actually take the place of the less reactive one. So the more reactive metal joins on to the other part of the compound, and the less reactive metal is pushed out on its own. So write that definition down, and again, it's a very important one to know. What we need to be able to do then is use something called the reactivity series. So this is the reactivity series. Now, obviously you could sit and learn the whole thing, or we could learn the bottom 5. Now, the reason I say learn the bottom 5 is because we've got hydrogen there in the 5th from bottom place. Now, hydrogen isn't a metal, but it's in there because obviously we need to know if it's more or less reactive than hydrogen to know if it's going to react with either acid or with water. And if we look beneath hydrogen, there are just 4 metals. So copper, silver, gold and platinum. Those 4 metals will not react with water and will not react with acid. Any others they give you on the exam paper will. So by learning copper, silver, gold and platinum, you know that if it's not one of those, we have a reaction with either the acid or with water. Obviously that doesn't help out in terms of a displacement reaction, but the types of questions that I've seen them ask on the exam papers have been around giving you a set of results and then asking you to create a reactivity series based on that. So I'll leave this up just for another 45 seconds, just in case you want to jot it down. When it comes to those displacement reactions then, what we've got at the top is the balanced symbol equation for one. So we've got copper reacting with silver nitrate to make copper nitrate and silver. What we can do from that is write the 2 half equations. Now half equations, remember, only focus on one of those reactants. So our first one, we're going to look at just the copper. So we start off with the copper solid, and we're then going to make copper ions, and it's going to be Cu2 plus ions, and obviously 2 electrons, because in order to change a copper atom into copper ions, each atom has to lose 2 electrons. And because it's losing 2 electrons, it's an oxidation reaction, because oxidation is the loss of electrons, reduction is the gain of electrons. If we then look at our silver, we start off with silver ions, so Ag+, and each silver ion is going to gain 1 electron to make silver atoms. So what we see there is we're gaining electrons, therefore it is a reduction reaction. So write down the equations and then see if you can finish the sentence at the bottom. This is an example of a redox reaction because ... Hopefully we finished off that sentence with because both oxidation and reduction reactions are occurring. Just before we finish this topic, then there's some really useful things that we can remember in terms of patterns. So what I'd like you to do is finish off each of these points, and the bottom one you can just write out. So I'll give you a couple of minutes to finish those ones off. Hopefully you wrote down group 0 are unreactive. Group 1 and 2 become more reactive as you go down the group. Group 7 become less reactive as we go down the group. And group 1 and 2 are more reactive than the transition or other metals. So give yourself a mark out of 3 for that bit. Two more sentences to have a go at finishing off, so I'll just give you a couple of minutes to do that. Hopefully what we wrote down is that metals may form ionic compounds with reactive nonmetals, and reactive nonmetals may form covalent compounds with each other. Final thing for today then are the plenary questions. So I'm going to leave these up on the screen for about 3 minutes, but as always, if you need longer to do them, hit pause and take as long as you need.